Started on today's discussion. So we have another equation problem we would like to have you try, and we're going to just drill these in until they're automatic. So we're going to distribute the 9 in that first part of the equation to both things in the parentheses. 9 times y would be 9y. And then 9 times 1 would be subtract 9. And all of that equals negative 8y plus 25. All right, very nice. All right, so let's move all of the y values to the left side of our great barrier here. So we're going to have 9y, and we're going to add 8 to both sides to get it off of this side. So plus 8y, and all of that is going to equal 25. And we're going to move this 9 over to this side, and it's going to become plus 9. All right, let's collect our like terms. 9 plus 8 is 17. So we have 17y equals, and we have 25 plus 9, which is 29, 30, 31, 32, 33, 34. So 17y equals 34. When we divide both sides by 17, we sure indeed get y equals 2. All right, so let's keep it going here. So today we're talking about classifying angles, and you're going to need to take some notes with this because these little definitions are going to come in handy. You're going to need to know them and apply them time and time again in these problems. So first of all, if I have a single angle and it's less than 90 degrees, it's called an acute angle. If I have a single angle and it's got a 90-degree angle in it, looks like this, straight up and down and over like this, that's considered a right angle. It's equal to 90 degrees. A single angle that is larger than 90 but less than 180 is considered an obtuse angle. And then any angle where the angle is opened wide up until it forms a straight line is considered a straight angle, or it equals to 180 degrees. And so if you think about it, you got 180 degrees on this side, 180 degrees on this side, which gives you a total of 360 degrees if you want to look at it that way. Okay, now a couple more definitions. When we talk about complementary angles, these are two angles that combined add up to 90 degrees. For example, you see a 30-degree angle, a 60-degree angle. 30 plus 60 equals 90. So these two would be considered complementary angles. And so it kind of looks like this. If you set the two together, you'll notice that the angles combined together will end up giving you a 90-degree angle in there on complementary angles. For supplementary angles, you have two angles whose sum is 180 degrees. So if you look at this definition right here, you've got a 135-degree angle here, a 45-degree angle here. If you split them together, those angles, 135 plus 45, would add up to be 180 degrees, which makes them supplementary angles. So in this case, you don't have angle measures, but you can see that these two angles, 3 and 4, combine to give you a straight line like this, which is also 180 degrees and supplementary angles. All right, so here's an example. Tell whether the angles are complementary, supplementary, or neither. Well, if we take the two angles, we got 110 and 70, and all we need to do is add them together. And this is a pretty good example, pretty easy example. So that ends up being 180 degrees. So that makes them supplementary angles. Okay, what about these two? You've got two angles here. You've got 64 and 26. Combine them together. You get 6 plus 4, which is 10. 6, 7, 8, 9. Oh, these do indeed add up to 90 degrees. So that would mean that they are complementary angles. All right, how about these two? If you take the two angles and sum them up, 70 and 19, Oh, look at that. They add up to 89 degrees, which is a pretty good number, but it's not quite 90 degrees, and it's definitely less than the 180 for supplementary, so it's not either any of those. So then this would be neither supplementary or complementary. Okay, find the supplementary and complementary angles. An angle measure is 82 degrees. What is the measure of its supplement? So all we need to do is go 180 minus 82 to find an angle supplement. 180 minus 82 would be 98 degrees. So a 98 degree angle and an 82 degree angle would add up to 180. Okay, an angle measures 60 degrees. What is the measure of its complement? Well, so if you got a measure of 60, if you add it to its complement, the two of them would add up to 90 degrees. So to find its complement, you just subtract 60 from both sides, and you end up with C equals 30 degrees. All right, keep it going here. So two angles are considered to be congruent if they have the same measure. So that's a really important one. So a lot of the problems we're going to do deals with looking to see if angles are congruent. So even though these two are kind of in reverse order from each other, you'll notice that they both have 60-degree angles, which means they are congruent, as well as these two 120-degree angles as over here. Okay, another definition for your notes. Two angles are vertical angles if they're opposite angles formed by the intersection of two lines. Vertical angles are considered to be congruent. So as you can see here, we have two lines that intersect each other at a common point right here. When that happens, you form four angles. Well, it turns out that the angles that are straight across from each other both form congruent angles. So angle 1 is the same as angle 3, and angle 4 is the same as angle 2. So if you can find any one of those angles, you can find all of those angles, knowing that relationship. So here we go. If two angles are adjacent angles, if they share a common side and have the same vertex. For example, angles 1 and 2 are adjacent to each other because they share a common side right here, and they have shared this vertex right here. So let's take a look then. Looking at this little demonstration right here, we have, look at this, we have two intersecting lines, which means we have what they call vertical angles. And we know that angles that are across from each other on this are considered congruent. So what would be congruent to 70 for x? It would be equal to 70 degrees, okay? All right, that's easy. Okay, how about these two? These two angles, if you notice, they add up to a straight angle or a 180-degree angle. So to find x, we just do 180 subtract 85 equals 90 degrees. Actually, I jumped the gun there a little bit. 180 minus 85, we better do that. So 18, 17, 10 minus 5 is 5. Okay, I was off a little bit. And 17 minus 8 is 9, so it's 95 degrees. So that's what x is. X is 95 degrees. Okay, keep it going. All right, these two angles, you got 69 and x. Well, if you notice, they add up to this little box here, which happens to be a right angle. So you've got 69 plus x equals 180 degrees, or which equals 90 degrees because of the way we got this stacked. So then we just subtract 69 from both sides. And we end up with x equals 21 degrees. So that's kind of cold, but there you go. Okay, moving on to the next problem. Okay, find the angle measures given two intersecting lines. So remember we told you that if you have two intersecting lines, that the angles straight across from each other are called vertical angles. And we know that vertical angles are congruent. We also learned that if you have two angles that add up to 180 degrees, like we have several pairs of those, these are equal to each other, and so on. So let's take a look at what this means. So it says a measure of angle 4 is 143 degrees. So that means this angle up here is 143. And then based on that, we also know that the angle straight across from angle 80, or angle 2 is 143 degrees. And the measure of angle 3, well, if you notice that angle 2 and angle 3 go together to form a straight line, which is a 180 degree angle. So if we take 180 degrees and subtract from it 143 or 143 degrees from that, you're going to end up with 37 degrees. So that angle is going to be a 37 degree angle. 37 degrees. All right, so you can see how we're using these angle relationships to do this. So if angle 3 is 37, then that also means that angle 1 is 37. All right, moving along here. Okay, in this figure, finding angle measures given the two intersecting lines. So the measure of angle 1 is 68 degrees. Since these are vertical angles, so the angle straight across from it will also be 68. Okay, now let's subtract 68 from 180. Oops, minus 68. So you end up with 18, 17, 10. 10 minus 8 is 2. 17 minus 6. So 17 minus 6, that would be 11. Oh, well, excuse me, 112 degrees. So that means each of these are 112 degrees, while each of these are 68 degrees. And 112 plus 68 equals 180 degrees, or a straight line. Okay, now we got a couple of problems where we're going to use a protractor. So use the protractor to find the degree measure of the angle. So they give you a protractor that you can grab in Alex, but I actually have one here that's a little easier for me to use. So when you use a protractor, you take this little 0, 0 dot, or the center of your protractor, and put it on there. And then the bottom of the protractor coming out on the 0 degree line lines up just like that. Okay, now in our case, we actually have a button that we can grab, click and hold down and rotate this protractor till that's in place, like that. Okay, so that would be a 15 degree angle. So 15 degrees. Okay. All right, so now we're going to talk about angle addition for a moment. We notice we got a couple of angles here, and right off the bat, they tell us that the entire span of this angle is 160 degrees. But then you also know that a part of that span, which is this section over here, equals 125 degrees. So if we know that's 125 degrees, and we know that the entire angle is 160, we can find x by just subtracting these numbers. So 160 minus 125 equals 150, 148 degrees. Okay, nice. So there you go. So that's what x is 140. Well, x is, well, the x isn't 148 degrees. It's 160 minus 125. I got a little bit carried away there. 6 and 5. So 10 minus 5 is 5. It's 35 degrees. I'm sorry, I got a little carried away there. All right, keep going. Oh, well, that's it. We're going to classify our doing our assignment on classifying angles. And so it looks like you got quite a wide variety to take a look at. So good luck today.